Here we have 3 rubber bands suspending a washer. Rubber bands are attached to a couple of lab stools, and these stools can be moved. We can see the directions of the 3 rubber bands, and they're pretty much parallel to the directions of the strings. I've attached the rubber bands to the strings with paper clips. Paper clips make convenient hooks. I could, if I wished, put a piece of paper, or some kind of a backing preferably, behind the system and mark both the directions and the lengths of all the rubber bands. I could mark the direction of this rubber band and the direction of this. I could mark this end and this end and this end and this end and this end here and this end down here in this direction. Okay, I could make all those marks, and from those marks I could determine what the vertical direction is, what the direction of each rubber band is, and the length of each rubber band. I can vary the directions of, or the angles of the system. I can move the benches closer. I can raise one rubber band higher than the other, make it lower, and we can see how the lengths of the rubber bands change as we change these angles. Okay, now somehow I think I've managed to stretch the system a little bit, but here we go. Now we're going to come back here. We can also see what happens if we add a little bit of weight to the system. Get this hooked on there. Okay, that's going to change the tension in the rubber bands, and of course I can pull down harder. Now, the procedure, the original procedure for this experiment had you using the rubber band balances, and I've decided that that's probably not as time efficient as just using plain rubber bands and marking their distances, marking their lengths on a piece of paper. We can mark these lengths, we can measure the length of the rubber bands, and from that we can determine the tension, because of course when we take the system apart, if we know the length of a rubber band, then we should be able to hang one of our known weights from the rubber band and determine what the stretch of that rubber band was and what the force on it was. So I think that by directly observing the rubber bands, or possibly just by calibrating the rubber bands with weights from the weight set, we can determine from the length the amount of stretch. Remember, we don't want to exceed about half the length of the rubber band. The stretch shouldn't be more than a third, and certainly no more than half the length of the rubber band, and we shouldn't leave the rubber bands under tension for any significant time. So if we're doing something else, we might just want to take the weights off here and let the rubber bands come back to their natural length. Otherwise they stretch out and the calibration won't be as accurate as we'd like it to be. But I think this procedure should work. I was going to suspend the car, the friction car, but the stools weren't tall enough and the table was a little bit too close. I couldn't quite support the weight of the car. The car came down and hit the table. But that makes a convenient object to use. You might want to use slightly heavier rubber bands. Again, gauge the rubber band you use by the fact that you should be able to measure the stretch of the rubber band, but that they shouldn't stretch out too far.